Okay, trigonometry, and as I've stated before, it is something you will not only use in this class, but something in Math 3. You'll also use it in advanced math and in calculus. Okay, we're going to talk about sine, cosine, and tangent. I'm going to write that down. Sine equals a fraction. I'll fill it in later. Cosine equals a fraction. I'll fill it in later. And tangent. Okay, going to draw a picture over here of a right triangle. When we first talk about trig, it's only used for right triangles. When you get to higher level math classes, you can use like law of sines and law of cosines, but for now, it's only on right triangles for a long time, even for next year. Even for your whole first semester of advanced math, it's only used on right triangles. Okay. I am going to pick an angle. It doesn't matter which angle you pick. I'm going to pick that angle down there at the bottom. Again, it doesn't matter, but I would suggest you label it the same as me for now. I'm going to call this angle A. Okay, now A could be up in this corner, but it's not ever at your 90-degree angle for now. Okay, A can be up at the top corner or the bottom corner, but not your 90-degree angle. All right, we're going to use words opposite and adjacent. And we're even going to use the word hypotenuse, but where's the hypotenuse in this picture? Opposite which angle? So this is the hypotenuse right here. Do you guys agree? Yes? And it doesn't matter where A is. If A is this bottom angle or the top angle, hypotenuse is always going to be opposite the 90 every single time. Okay, but your opposite and your adjacent are going to vary depending on where your angle is. So I'm going to jump across. Am I pointing right now to the opposite side or the adjacent side? This is the opposite. Can you guys see that? Going across that way is opposite angle A, yes or no? Okay, what I'm pointing to, adjacent means next to. Is this side here adjacent or opposite angle A? This is adjacent. Can you see that? Okay, now some kids will be like, well, this is also adjacent. Yes, it is. These are both adjacent to angle A, but this side has a special name. What is this side called? What is it called? Hypotenuse, all day long, every day. So this is adjacent, that one's hypotenuse, that one is opposite. Now, if I was sitting up at this corner, I'm not going to relabel anything, I'm just going to say it. If I was sitting up here at this corner, what would this side be called, opposite or adjacent? If I was sitting up here, this would be opposite. Can you guys see that? I can see some of you guys are not paying attention. You want to be. If A was up here, this would be opposite, and this would be what? Adjacent. So it all depends on where you're sitting. All right. Questions on that so far? All right. Sine of angle A, and I'm going to put cosine of angle A and tangent of angle A. Okay. Sine, it will always be your opposite side over your hypotenuse. It's always going to be a ratio, a fraction of your opposite leg over your hypotenuse all the time. Cosine will always be a ratio of your adjacent side over your hypotenuse. Your adjacent leg over your hypotenuse. Every day, all day. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent will always be opposite leg over adjacent leg. So what's going to happen is you'll be given numbers today, and they're going to ask you what sine of A, and you're going to give it to me as a fraction, 3 over 5 or 4 over 3 or whatever it may be. Got it? Do you have to have this here memorized? Yes, yes you do. You need to know that sine is opposite over hypotenuse. You need to know that cosine's adjacent over hypotenuse, and you need to know that tangent is opposite over adjacent. It's just something you will flat out need to have memorized. There is an acronym that people have made up in the past. Now, when I was in high school, I didn't learn it this way. I just flat out memorized it. But since then, this has come up, so I'm going to share it with you. Okay, SOHCAHTOA is what it's called, SOHCAHTOA. You'll hear it if you ask anyone who's taken this class or anyone in Math 3 or Advanced Math, you know what SOHCAHTOA is? They'll tell you yes, they've heard it before. SOHCAHTOA. Okay, I know it sounds weird, but it works. And I will tell you this, when you take a quiz or a test or even do your homework, I suggest you write this down up at the top, and this is going to help you to memorize this. I'm going to show you how it works. First, do some of you see it already? Okay, I will tell you this. This is, the SOHCAHTOA is not a formula. It's just, do you remember PEMDAS? Do you remember PEMDAS from like middle school? Please excuse, what was the rest? My dear Aunt Sally. It's an acronym. That's what this is. It's just to help you memorize this here. Okay, what do you think the uppercase S stands for? Sine. What about this, the big C? Cosine. And T? Tangent. Okay, so this is telling us sine is O over H. What do you think O and H stand for? Opposite over hypotenuse. Do you guys see how that works? And then cosine is what? A over H? Adjacent over hypotenuse? And then tangent is what? Opposite over adjacent. All right, so I'm going to have you just really quick not look down at your notes, so cover them if you can, or just not look down. So you're doing homework or a quiz or a test, and they're asking you for all the sine, cosine, tangent. First thing you should write down is SOHCAHTOA. How do you spell it? S-O-H, SOHCA is what? And then TOA is SOHCAHTOA. All right, and then you write down sine of A, or whatever angle they give you, is what's O over H. Without looking down at your paper, what is O over H? Opposite over hypotenuse. What does C stand for? Cosine of your angle, whatever it may be. A over H, what does A stand for? Adjacent over hypotenuse. And then what does T stand for? Tangent of A, whatever angle they're asking for, is O over A, which is what? Opposite over adjacent. All right, do you guys think you could do that on your own? Yes, all right. So again, that SOHCAHTOA is not a formula. It's just a little tool we use to help us memorize what sine, cosine, and tangent are. I will tell you this. Shorthand for sine, we just write S-I-N. It's not sin. We still call it sine. Shorthand for cosine is C-O-S, not cos, still cosine. And shorthand for tangent is T-A-N. You could call that tan, I don't mind. I just don't want you calling that sin or that cos. Sine, cosine, or cos even I will accept. Tangent or tan. Just don't call that sin. All right, are we good? What? No? All right. Oh, why? Is that what you're asking? Just because it sounds wonky. I don't like the way it sounds. I mean, I'm not going to dock you points if you call it sin, but it's not. It's sine. Okay. Examples. Number 1, find part A. I want you to find sine of A, cosine of A, and tangent of A. And I've abbreviated all of them. Sine, cosine, tangent. Part B, I want you to find sine of B, cosine of B, and what's the last one? Tangent of B. All right, I'm going to draw the picture over here. This is A, this is B, and this is C. I asked you to find sine, cosine, tangent of both A and angle B. Why did I not ask you to find it for angle C? Because it's 90. You are correct. And we don't ever do sine, cosine, tangent, and 90, at least not in this class. Okay. I'm going to tell you that AC is 4, BC is 3, and AB is 5. Those lengths are given to you. This is 3, this is 4, that is 5. So far, so good? All right, part A, I want you to find sine, cosine, and tangent of A. Okay, so here's what I'm going to do. I'm going to work in pencil because I am going to erase. So if you're working in pen, don't write everything down and change to pencil if you can. Okay, first one they're asking me for is angle A. So I'm going to put a dot here. Angle A is where I'm working from. How do I know that? Because part A asked me to use angle A. Okay, regardless of where I'm sitting, which side is my hypotenuse? Opposite the 90, what's the value? So this is the hypotenuse. That one I could write in pen because it's not going to change. Okay, now sitting here at the A, what is the 4? Opposite or adjacent? Adjacent. Sitting here at the A, what is the 3? Opposite or adjacent? Okay, so label your hypotenuse first, and then your opposite, adjacent. The order in which you label those doesn't matter. Remember, kids will say, well, this is also adjacent. Yes, it is, but it has a special name, and it's called the hypotenuse. Okay, so that's all we need to now find sine, cosine, and tangent. Sine of A. What is sine? OH, what over what? Opposite over hypotenuse. So what's opposite in our picture? We have it all labeled. 3 over hypotenuse, which is 5. And then you reduce if it's reducible. Does that reduce? No. Okay. Cosine of A. Cosine is what in words? Adjacent over hypotenuse. So it's all labeled for you. What's adjacent over hypotenuse? 4 over 5. Does that reduce? So you're done. All right, tangent of A. Looking here, what is tangent of A? What is tangent in words? What over what? Opposite over adjacent. It's all labeled. What's opposite over adjacent? And does that reduce? Nope. So that's it. You're done with part A. Any questions? Do you agree once you label your sides appropriately, it's not really that hard? Okay. Any questions on part A? Part B is asking me to do the same thing, but now for which angle? B. So I'm going to take my pencil, I'm going to erase the marking there. I'm going to mark B. And what is the hypotenuse going to change, or is it still going to be called the hypotenuse? The hypotenuse is always the hypotenuse. But what is 4 now in reference to B? Is it still adjacent, or does its name change? What does it change to? Opposite. And in reference to angle B, what would you call side 3? What is that one there? Do you guys see that? Yes or no? Okay, so now we're going to do the same thing. Sine of A, sine of B, cosine of B, and tangent of B. All right, what is sine of B? What is sine in words? Looking back at our SOHCAHTOA, what is sine in words? Opposite over hypotenuse. It's all labeled. What's opposite over hypotenuse going to be as a fraction? Does that reduce? All right, cosine of B. I'm actually going to have you write these two really quick. I'm going to give you guys a few seconds to write those two on your own. All right, do we have it? Diego, can you give me cosine of B? 3 over 5. Do you guys agree with him? Ellie, can you give me tangent of B?
4 over 3.
Do you guys agree with her? All right, questions on those? Do we agree it's not that bad? If you know how to label things and you label it first, it's not going to be that bad. I do recommend you work in pencil on your homework because it's going to have questions like this where it switches from angle A to B and you're going to want to rename things. Yes?
Are there sine and cosine, are they like always opposite?
Very good question. Very good question. And I was about to lead up to that, and it's even better when a student leads up to it for me. Okay, repeat your question again.
Are sine and cosine always opposite?
Okay, be more specific.
Like for each angle are they opposite?
Like sine of A equaling,
Cosine B.
okay, and then cosine A equals sine of B. Is that what you're asking?
Yeah.
Will that always work? Any thoughts? Okay, it is a test question, by the way, so I'm glad you asked. Okay, let's check. B's opposite is A's, okay, 4 is B's opposite, but it's also angled A's what? Adjacent. Do you guys agree with that? And B's adjacent is also angle A's opposite. So will sine of A always equal cosine of B? Is that always going to happen? Yes, that is always going to be true. Will cosine of A always equal sine of B? Yes, because one's opposite is the other's adjacent. One's adjacent is the other's opposite. Do you guys see how that works? They have a special name, by the way. They're called complementary cofunctions. That you don't need to know until advanced math, but that's what they're called, complementary cofunctions. So they will ask you this on the test, and you should know that sine of A, sine of one angle in the same right triangle, will always equal cosine of B, of its complement. These two are complements because they add up to 90. Questions? Okay. Let's move on. Number 2. Oh, and was there a relationship between the tangents? They're not equal, but they are something. That's not a test question, but I'm just pointing it out. What do you notice about these? They're not opposites. Yeah, on the right track. They have a, what is it? Reciprocals. They're reciprocals of each other. Okay. Number 2. Find sine of A, cosine of B, and tangent of A. So I'm asking for different things, different parts. All right, let's get our picture down first. Again, sine, cosine, tangent. When you're doing SOHCAHTOA, SOHCAHTOA can only be used on right triangles. Opposite over adjacent, opposite over hypotenuse, that kind of stuff can only be used on right triangles. All right, A, B, C. CB or BC is 5. AC is 15. And that's all that's going to be given to you. In order to find sine and cosine, do you need to know what the hypotenuse is? If they don't give it to you, what can you do? What do you have to do? I heard like 2 people whisper it. If they don't give you the, whether it's the hypotenuse or not, if they do not give you a third side, they only give you 2 sides, what are you going to do to find the third side? Pythagorean's theorem. Do you guys agree we can use Pythagorean's theorem? What am I looking for here? One of the leg lengths or the hypotenuse? I'm going to put the C here. I'm going to erase it in just a bit. So 15 squared plus 5 squared equals C squared. Did I set that up properly? If it was one of the legs missing, then you would have something like you would have something like 15 squared plus B squared equals a number squared. It all depends on what is missing. In this case, it is the hypotenuse. All right, what's 15 squared? 225, good job, plus 25 equals C squared. Add these two together, what do we get? 250 equals C squared. And then what do we do to both sides? Square root, why do we square root? What happens with the square root and the squared? They undo each other. They're called inverse functions. That's the whole reason why we do that, is so that they would undo each other. C equals root 250. What do we have to do to the 250? I heard somebody whisper it. Thank you. Break it down is correct. Now there's a variety of numbers you can use. I'm going to use 25 and 10. Why is 25 and 10 a good set to use? Because 25 is what? A perfect square. Do you guys agree? 10 is 5 and 2. So I have 2, 5, 5, 5. Do I have enough for a pair to come out? One pair or two? Just one. Does it come out as 5 or 25? So this comes out as 5. And what stays in? 2 times 5 is what? So 5 root 10 is what I hear you guys saying. Yes or no? So the hypotenuse is 5 root 10. So will you have to remember how to use Pythagorean's theorem even into these other lessons? Yes, you learned it last year, year before. It's something you've known how to do, and we're still using it for these type of problems. All right, sine of A. Since I'm going to be erasing, I'm going to use pencil. I'm going to put my A there, my dot there, because that's where A's at. And I'm going to start to label. The one part that's always going to stay the same is the hypotenuse. Where's the hypotenuse in this picture? Okay, I'm going to call this hypotenuse. Okay, what am I pointing to? In reference to angle A, what is 5? This is the what? Opposite. And what is the 15? Adjacent. Okay, sine of A is, oh, we didn't write it down. What is it? So, ka, toa. And what is sine in words? Opposite over hypotenuse. We have it all labeled. Write it down on your paper. Opposite over hypotenuse. Rebecca, can you tell me what that is? What over what as a fraction?
5 over 5 root 10.
Do you guys agree with her? Can I reduce anything here? What reduces? The 5s, because they're not in radicals. So I'm left with root 10 or 1 over root 10? 1 over root 10, right? Because the root 10 that's left over is left in the bottom, so it's still in the denominator. Do you guys see how that worked? Can anybody tell me why, if I stopped there and boxed that part in, why I would get that part wrong? There can't be a radical in the denominator. Does anybody remember what the process is called? It starts with an R. Rationalize. Good job. What do I multiply top and bottom by? Root 10 over root 10. Why root 10 over root 10? Because root 10 over root 10 is equivalent to what number? Root 10 over root 1. And 1 is called the what? The multiplicative identity. Meaning if you multiply by 1, do you change the original value? No, you're going to change the way it looks, which is what we want. 1 times root 10 is root 10. And the whole reason we picked root 10 is so that there would be a what? A pair. Without saying 100, what's root 10 times root 10? What? Is it just 10? That is your answer for sine of A. Is that complicated? It is, but that's why we talked about rationalizing that week before break, is so that when we get to this point, we have at least some practice. We've seen it. We're going to do another one. I did mess up. Right here. I didn't mean to put that as a B. That should be an A. It could be a B. There's nothing wrong with it. I'm going to put it to A. Cosine of A. All right. Looking here, what is cosine in words? Good job. Adjacent over hypotenuse. You have it all labeled. That's what over what? 15 over 5 root 10. Does anything reduce? The 5 and the 15. What goes into both the 5 and the 15? 5 goes in. You said leaving the 5 as 1 and the 15 as 3. So I'm left with 3 root 10 or 3 over root 10? 3 over root 10. I'm going to let you rationalize that one on your own. Can you guys at least tell me what you would multiply top and bottom by? Root 10. Good job. Heads up off the desk, please, and getting to work. Can you nudge him behind you, please?
Oh, all right.
Okay. Thank you. Okay, what's 3 times root 10? 3 root 10 or root 30? 3 root 10, good job. Over, there's a pair here. What does that become? 10. I forgot to ask it earlier, so I'm going to ask it now. Can I reduce these two 10s? No, because one is a radical, one is not. What about the 3 and the 10? These I could reduce if it's reducible. Is it reducible? No, that's your final answer. All right, what's the last piece? Tangent, and what is tangent in words? It's all labeled for you, so what is it? 5 over what? And does that reduce? Good job. We can divide top and bottom by 5, and you said that's 1 over... Do I have to rationalize this one? Nope. Thank goodness. That's it. That's our answer. Questions? Does it make sense? Okay, that's it for this lesson.